Hello everyone, this is part 2 of the presentation made on the course data communication. So, in part 1 we saw the an introduction to the subject and where we are standing, everything we saw. I already told you we are dealing with the physical layer. When two machines are trying to communicate each other, what about the properties of the medium and how the communication is happening, the encoding techniques, those things are coming on this course. So, we are moving on to the actual contents to be studied in this in your first module. So, let me start with some of the transmission terminologies. Data transmission occurs between a transmitter and a receiver, or a sender and a receiver, over some transmission medium that we already seen. And now the transmission, medium and media is a plural form. Transmission media can be classified as a guided media or unguided media, and all are very fundamental concepts only. I am just reading out. Whether it is guided transmission or unguided transmission, in both the communication is actually in the form of electromagnetic waves. That means from your machine, that binary should be converted into electromagnetic waves, and at the receiver it should be, we call it as encoding and decoding, that binary to signal conversion encoding, and at the receiver side decoding of the signal back to the format that is supported by your machine. Okay, so in the medium, whether it is a wired or wireless guided or unguided medium, the information will be communicated in the form of electromagnetic waves. So, if you are looking at a guided media, what is a guided media? The waves, that is electromagnetic waves, are guided along a physical path. That means we have a path and the information is going through that path only. Okay? But when it comes to wireless communication, you can't say like the information is going exactly through this path. It is not like that. It will be going through anyway. So, if such a guided path, a particular specific physical medium, the path is there, it is called guided communication. Example, the twisted pair, coaxial cable, optical fiber, we know that, and you can see that the massive physical device, optical fiber or a coaxial cable or a twisted pair cable, and through that cable, through that the path provided by the cable, the waves are traveling. So, that is the case of a guided transmission. But when it comes to unguided transmission or unguided media, that is also called the wireless media, that provides a means for transmitting the electromagnetic waves, but do not guide them at all. That means there is no particular physical path for the information to travel. So, that is the difference. So, guided media is nothing but the wired means of data transmission, and unguided media is nothing but the wireless means. Okay. So, examples are the propagation through the air, vacuum or seawater, whatever it is, there is no physical path, that is. Now, some of the terminologies involved, we are already discussing terminology, some more terminologies. There is a terminology called direct link. I told you already, direct link means there is no intermediate devices in between. So, it could be a hop like what we see in the part 1 between two adjacent routers, we call it as a hop. There is a direct link, right. So, the term direct link is used to refer to transmission path between two devices in which the signal propagates directly from the transmitter to the receiver with no intermediate devices. There is a direct communication. Other than the, see, these amplifiers and repeaters are exempted, which are used to increase the signal strength. The amplifier will amplify your signal to a more strengthened one, and repeater is doing what? It is just even though I am writing like amplifier or repeater, see there is a main difference between these two devices. Just understand that we have this electromagnetic wave which is normally taken the form of a sine wave, and the sine wave is having a property called amplitude, and those things I am discussing further and those who know, it is clear, right, that the height of that particular signal, amplitude. Now the amplifier is the one which is increasing the amplitude. So that is the duty of that, so that your signal will be of more strength. Now when it comes to repeater is not amplifying, but instead there is something called attenuation, signal attenuation. Even though the signal is going with a specific energy, after some time it will lose its energy and the amplitude keep decreasing, and that time just regenerate the signal. So that is a correct term, regeneration of the signal. You have to regenerate it back to the original format. You do not have to amplify it further. You have to do amplification, but that is only for the regeneration of the signal. So that is what is done by the repeater. Amplifier is further boosting the signal strength, okay, and these things are exempted. So when you are looking at a direct link between two machines, the amplifiers or repeaters can sit, because they are simply regenerating the signal and they are or amplifying the signal, right. So they can sit, but other intermediate devices like a router, gateway, those things are not allowed, okay. That is the concept of direct link. So just remember the exemption, that the amplifiers or the repeaters are allowed. Note that this term can be applied to both the gated and ungated media, that is our wired and wireless device. Even though it is wireless, still we have access points like routers, and those things should not come, and there is a direct communication between two devices in a wireless way. That is also direct link. Same terminology you can apply both to wired and wireless communication. A gated transmission medium is called a point-to-point transmission if it provides a direct link between two devices and those are the only two devices sharing the medium. The term itself says that what is point-to-point, one-to-one or point-to-point means only two devices are involved in communication and they are the endpoints, and no one else is sharing the medium. So the medium is exclusively shared by two devices sitting at the two end of the medium. That is what is called a point to point. So definitely the next term will be the multi-point communication, where we have a common medium and that medium will be shared by more than two devices. Okay, let me show you how it is happening. So this is your medium. If one device is sitting here and another one is sitting here, that is our point-to-point communication. But when it comes to say multi-point communication, so this is one device connected to the same medium, say another device connected to the same medium, now say a third device that is also connected to the same medium, say etc. Like that, there will be more than two devices which are sharing the common medium. That makes the communication a multi-pointed communication. Particularly note down that this classification is for gated transmission. Then only we have a specific physical path and you can say that this physical path is being shared by two devices, then it is point to point. It is shared by say n number of devices, that is multi-point. Wireless, there is no such terminology, okay, because there is nothing like this. Instead of that we have a wireless medium. That is why this terminology point to point and multi-point is applicable to gated medium only. So that is another terminology. Now we are moving on to something called a transmission mode, different ways of communication. The transmission mode defines the direction of signal flow between two connected devices. When two devices are connected each other through wired or wireless, what is the direction in which communication is happening? Whether the communication is in one direction or in both direction, whether if it is both direction, whether it is happening simultaneously or one after another, and that is what is called the transmission mode. And we have different transmission modes. Mainly three modes, that is the simplex communication mode, half duplex and full duplex mode. It's very simple concept, we will see each. What is simplex communication? In simplex transmission mode, the communication between the sender and the receiver occur in only one direction. I already told you, say from the sender to the receiver or from the receiver to the sender, whatever it is, communication is always in a single direction. If I am telling to you okay, I can take this class as an analogy. I am communicating with you only, but if you want, you can give me the feedback through the comments and all. Or through your classroom, but that is different. But here I am saying that the receiver is not able to respond back to the sender, that is the idea. So, the communication is only in a single direction. The sender can only send the data and the receiver can only receive the data. The receiver is not allowed to respond back. The receiver cannot reply back to the sender. The basic example is our keyboard monitor relation. You know, through your keyboard you will be typing some information and you can see them in your monitor. But from monitor nothing is given back to the keyboard, right? Keyboard is always giving some information to the monitor, but monitor is, so it is one direction, right? So, keyboard monitor relationship. The keyboard can only send the input to the monitor and the monitor can only receive the input and display it on the screen. The monitor cannot reply or send any feedback back to the keyboard. So, that is a simplest example for the simplex communication. Or normal say radio communication, you are all receiving that information, you are not responding back, right? The radio broadcasting, television broadcasting, all those things are examples for simplex communication. The simplex mode can use the entire capacity of the channel to send data in one direction. So, we have a medium involved here also, but that medium is exclusively used for communicating only in one direction. So, that is actually a limitation of this. Even though it can be utilized for two directional communication, but we are using it only for a unidirectional, one direction communication. And another, the next level, that is the middle one out of the three, the middle one, that is the half duplex communication. So, definitely the previous one is allowing communication only in one direction. So, definitely this will be allowing communication in both directions. But what is happening here, the communication between the sender and the receiver occur in both directions in half duplex communication, but only one at a time. That is the concept you have to keep in your mind. At any time, either the sender can communicate with the receiver, that time receiver has to be silent exclusively, it is not allowed to interrupt. After the sender to receiver communication is over, the receiver is allowed to communicate back to the sender, but simultaneous communication is not possible. You all may be getting an example of it, right? The walkie-talkie that is used by the police officials, and you know what is happening in walkie-talkie, right? That is purely an example for the half duplex communication. The sender and the receiver can both send and receive information, that is both direction is possible, but only one is allowed to send at a given time, that is the point. Example, the walkie-talkies, the speaker are at both ends can speak, but they have to speak one by one, that is over, that means my direction is over, next you can speak, like that. Some signal is to be sent whenever I am finishing my communication, so that the other one can communicate. Anyway, that medium is supporting only one direction at a time. Both are fine, but both should not be done simultaneously. They cannot speak simultaneously. Here the entire capacity of a channel is taken over by whichever of the two devices transmitting the data. The entire capacity will not be shared actually, it is given for both direction, but at any time only one is communicating, right. So, he will be taken care of the entire communication, he will be getting the entire medium capacity. Now, the last one, of course, the full duplex. You can guess, in simplex we have a communication only in one direction. In half duplex we have communication in both directions, but only one at a time. So, definitely in full duplex it has to be communication that is happening in both directions simultaneously. Here there is no restriction like one has to wait for other, at any time the other one can interrupt. Okay. So, that is our normal communication, your telephonic communication, or right, when you are using phone, both people are talking at the same time, other is listening, but some understanding is there, that is different. Okay. So, in full duplex communication mode, the communication between the sender and the receiver can occur simultaneously. The sender and the receiver can both transmit and receive at the same time, that is the concept. For example, in our normal telephone communication, telephone conversation, two people communicate and both are free to speak and listen at the same time, and there is nothing like one has to finish, nothing like that. So, in full duplex mode offers the best performance model among all the three. among the three on account of the fact that it maximizes the amount of bandwidth available. So, the medium is having some bandwidth, the capacity of the medium simply, and that is maximally utilized because both communication is happening simultaneously, not one by one. Hope you are clear about it. So, in full duplex mode, the signals are going in one direction, share the capacity of the link with the signals going on the other direction. Here that sharing is happening, right. The sharing can occur in two ways. Okay, now how this sharing is happening, this concept we will see in detail later, but I am just briefing. To share the communication medium, either the link must contain two physically separate transmission paths, because without any overlapping both of them has to send their information in both directions. Currently our computer network is providing us that. Like when two machines are connected by means of our any kind of cable, like coaxial, optical fiber, whatever it is, both simultaneous communication, that is by default all our network cables, everything are supporting this full duplex communication because it is giving the maximum utilization of the capacity of the medium. Okay. So, here one of the model is within the medium you can use two physically separate transmission path. So, the total medium is divided into two, one is for one direction, other is for other direction. So, there is no overlapping, nothing. You can think of the two-way road, it is separating like this, and that vehicles are moving in both direction, but one is following that particular set of path, other one is following a differently separated path, okay, something like that. But the problem here is sometimes the one side will not be used at all, like sender may be say machine A and B, A may be sending to B, but B may not have information to send back to A, and in that case the other part that is dedicated is getting wasted, right. So, that is a problem of providing two separate physical transmission path for making this full duplex communication possible. But instead if you want to utilize it more, that means without any, you should not, here you can see a kind of reservation. The total path you are dividing into two, and first half you are reserving for one direction, second half you are reserving for other direction, and you are making the communication both simultaneously. And when you are reserving like that, if it is not utilized by the other party, that is getting wasted, and that should not happen. So, we have another model called the capacity of the channel is divided between the signal both direction. That means here divided in the sense it is not a physically separate transition path, but using some other technique the total capacity we are dividing. And here the speciality is who is if A to B we want to send more, accordingly proportionally we can give. Other one if sending less, that resources which are not utilized by the other direction can be given to the other one also. So, that kind of a possibility is also there for implementing the full duplex communication, and how this is happening that you have to understand some technical details more, that we will see later. Okay. So, that about the full duplex communication. Now, just a comparison for among all the three, the half duplex, simplex and full duplex communication. The direction of communication, simplex unidirectional, half duplex bidirectional but one at a time. Here bidirectional and simultaneously. Send and receive. Sender can only, what is happening to sender and receive, can only send the data one direction. The sender can send as well as receive, but one at a time. Here again simultaneously. Performance, the worst performance mode, right. This is the best performing mode of the transition and better than simplex, sitting in between. The keyboard monitor relation and the walkie-talkie half duplex example, full duplex telephone. Okay, just some 4 points comparing these three. Now, this is something important just for your additional information. The definition just given for transition modes are the one that is commonly used in United States, that is as per the ANSI standard. We explained the meaning of simplex, half duplex and full duplex, but we have some other standards also. There are many standardization, and ANSI is one of the standard one that is used in United States, and another standardization say ITUT definition. According to ITUT standards, the term simplex is used to corresponds to half duplex, as defined previously, and duplex is used to correspond to full duplex. But that means, so let me expand the terms, and this ITUT stands for International Telecommunication Union hyphen telecommunication, and this is American National Standards Institute. As per ANSI standard, we have half duplex, full duplex and simplex, 3 modes of communication. But when it comes to ITUT standard definition, there is only 2 modes of communication, that is simplex and duplex. And the term simplex they are using for representing the half duplex we learned so far. Okay, what are all the definition I given for half duplex is what they call as just simplex. That means so far we discussed 3 modes: simplex, half duplex and full duplex. When it comes to ITUT, there is no simplex. Okay, what are all the concepts we learned in simplex was not there. Instead, they have a half duplex and full duplex, that concept, and that half duplex concept they are calling as simplex, and the full duplex concept they are calling as duplex. Okay. Why I am telling you it clearly is, if you are looking at some gate questions and all, you may be seeing that there is a duplex link, and that time you should understand what is duplex, because we know half duplex and full duplex, which is that. So duplex simply means full duplex. Okay, half duplex particularly we call as simplex when it comes to ITUT standard. Okay, so you should not be confused by looking at the terms. Okay, with this I am winding up part of the presentation, and here we discussed the transmission modes and some of the transmission. We begin with these transmission terminologies, then we mainly focused our attention on the transmission modes. Okay, thank you.